Hello and welcome to an installation, calibration and testing video from RC Empire. In this video we're going to be taking a look at the Turnigy Trackstar 30 amp 1/16th scale electronic speed controller and fitting it to our Losi Mini 8. Now a little background before we get started. I've had this buggy since 2014. I got it second hand and it is such a fun little car. It's got great adjustability, it handles great and it runs great, and it's a perfect size. Normally I keep this buggy in the back of my big car or chuck it in my rucksack if I go out for the day. In stock condition, running with our 3S Lipo, we actually hit 29 miles per hour, which is a very decent speed, and I've been running it pretty hard on 3S for the last 4 years I've had it, with no real issues. The only thing you have to be careful of is meshing the spur gear. When you get it spot on, it will last a long time, but when they do strip, it is a real pain to replace. Up until a few months ago, this buggy was 100% stock, until I was running it one day and suddenly the motor shaft just snapped, as you can see here. And actually, I've read quite a few other people have had this same problem, because it's only a 2mm diameter shaft. And what's weird is that the actual shaft diameter inside the motor is 3mm, and you can just about see that they've reduced that down to 2mm, and that's where the shaft has failed. And the replacement motor for this was quite expensive at £36, if you can find it anywhere that is, or for the newer equivalent version, the Dynamite Fuse 4500KV, it's £56 for a motor with a 2mm shaft that will probably snap again. So I found the Turnigy XK2445-4700KV motor for £12. I did think that because the motor kilovolts were around the same as the old motor, it would work with the original MSC-18BL HP speed controller from Losi, but unfortunately it didn't. And as you can see, we were getting a lot of cogging with the motor, over around 50% throttle. I even tried changing down the gears, putting in a smaller pinion to reduce the load on the motor and the current draw, but that made no difference at all. So we got the Turnigy 30 amp 1/16th scale ESC, which should work with this car and motor, and that's what we're going to be looking at and installing today. Now, the new ESC only cost us £15, which is really good. As you can see, it has a peak current of 180 amps and it's compatible with 4 to 9 cell NIMH batteries and 2 to 3S Lipos. Just a quick note, you can see there that it says 2435 size motor. Now this number means 24mm motor diameter and 35mm motor length. So our motor code is XK2445, so it's a 24mm diameter and 45mm long. If we open up the box now, you can see our brand new speed controller held in place with this plastic casing. And if we remove this quickly, underneath you have a few bits and pieces. So, you have a spare power switch cover with a few screws. You have some heat shrink tubing and a double-sided sticky pad for holding the speed controller on. You've got some zip ties, a couple of Turnigy stickers, and a little programming setting card here. And finally, you've got the instructions, and these include calibration, ESC setup, as well as some instructions on how to program certain features on the speed controller, like drag brake or running mode, and we might look at that in another video. And that's it for inside the box. Now, onto the speed controller, and straight away, it feels like a really nice, solid little unit. Here, you've got an on and off switch with a calibration button, your plug to go into the receiver, and this really nice connector. I've actually never used one of these connectors, but it does feel really nice and gives you a nice grip for when you're disconnecting batteries, especially compared to the Dean ones, which are a real pain to pull apart, especially if your hands are wet or cold. And inside there you've got these little banana type connectors. Now if we take our ruler, just to give you a little idea of the size of the speed controller, it is 36mm long, 28mm wide, and actually the box says it's 16mm high, but with the heatsink it's 20mm high. The plastic casing is 16mm, but the whole thing is 20. Quickly, you get about 60mm in length of wires for the battery cables, and again about 60mm for the motor cables. And if you wanted to know, this particular connector is 115mm wide, and actually maybe that is a little bit too big to fit under the body of the Mini 8. So to fit it, we first want to remove the old ESC, and this one is held on with 2 zip ties and a sticky pad underneath, which you can just cut off and clean up later on, as you will see. Disconnect all the wires. And here is the old Losi speed controller. I'd say in terms of length and height, it's pretty much identical. But the Losi one is a little bit wider, and it also gives you slightly longer wires, which on this car you don't necessarily need. Now one thing to note here is that we have swapped the battery connector for a DIN one, because all our batteries have DIN connectors, and even though the old one was quite nice, I have a ton of DINs in the toolbox to use up. What you can also see is that we have cleaned up the double-sided sticky pad, and I've used this Auto Gleam intensive tar remover and some methylated spirits to do that. Before we fit and secure everything into place, we are going to plug in the speed controller, calibrate it and give it a little bit of a test, just in case it doesn't work. So connect it up to the motor and to your receiver. And plug the battery in. Make sure, before you turn anything on, that you have the wheels off the ground, just in case it decides to start in full throttle or something and it goes flying. Now if we turn it on, you can see it seems to be working. If we get the instructions quickly, you can see again that this is a pretty standard method of calibration. So let's calibrate it. Turn on the speed controller whilst holding the calibration button and it should start beeping. And then you can release the button and you are now in calibration mode. Now, keeping the transmitter throttle in neutral position, push the calibration button once. Then pull the throttle to 100% and push the calibration button again. Then push the throttle to 100% reverse and push the calibration button again for the final time. And that's it, it should be ready to go. And if we give it a little test run, as you can see, we can throttle it to 100% with absolutely no cogging. And we've got reverse. And we're also getting some really nice ballooning of the tyres. And I would call that a successful first test. And now we can go on to securing all the parts in place and getting this buggy to the track. Now on to fitting it into position, which with this car and this body is quite fiddly, because there really isn't much room to play with under the shell and you really have to squeeze everything in. Depending on what control units and electronics you're running, you're just going to have to play around with them and see what works for you. But once you have everything in position and you've planned it all out, you want to secure it all down. Now in this case, I've used this thick sticky back tape to hold everything down. You just want to cut a small section, stick it onto the back of the unit. And then stick the unit down onto the chassis wherever you want it. Make sure the surface is clean, and also make sure there is no cleaning fluid or oil sitting on the surface where you are going to sit it down. Actually, what you could also do is put a long strip of Velcro onto that top part of the chassis and a little bit of Velcro under the speed control and receiver, and move and adjust the speed control and receiver wherever you want without having them permanently stuck down. And the Velcro will do a good job of keeping them secure. And with the speed control in place, give it a good push down and you can see it's strong enough to lift the car from. It's not a heavy car, but this is plenty good enough. And finally, get a couple of zip ties and tidy up all the wires and cables, just to neaten them up a bit and keep them from getting caught in any of the mechanisms. And finally, stick the on and off switch somewhere which is easy to get to. And actually, I think on this model, the best position for that would be just behind the steering servo on the chassis, because you can reach it there without having to take the body off every time you turn it on and off. Now with this 2200 mAh Lipo, I had to cut a bit of the battery tray out so it would fit in. But to secure it in place, and something I've done from the very start with this buggy, and which has worked really well, is to use Velcro. I've also stuck down this little section of foam which you can get from a craft shop just to give a nice flat flush platform for the battery to sit on. So what you want to do is stick a piece of Velcro onto the chassis and one onto the battery and just slot the battery in. And what's good is that the shell will also keep the battery secure with those little lower side sections. And that is pretty much it. You can fit the body on, make sure you're not crushing or cutting any of the wires, and you're good to go. And by the looks of it, there seems to be no issue with the motor or electronics of this car. So hopefully we'll be hitting the track soon, on road and off road, and giving this a real test run to see what the new motor can do. And see how it compares to the old motor that got us up to 29 miles per hour on this battery. And that's it. We will be back soon with some fun running videos, and maybe even a little race with this and our TT01 or even the TT02. So I hope you've enjoyed the video and got an idea of what kind of alternative power systems you can put in this little buggy. If you have any questions, drop us a comment below or email us, and please rate and subscribe. Thank you for watching and see you soon.